Hi, I'm Tyler Bishop.
I'm Scott Toth.
Hi, I'm Brennon LeCave, and we're working on a computational model of a pressure drop through an aneurysm. And so first I'll explain the anatomy of the aneurysm. So this is a normal aorta width. Aneurysm actually causes this bulge. So the first step in finding that pressure drop is we used ANSYS to computationally model the oxygen flow through this aneurysm. So this is an example plot of the oxygen concentration that we found of the aneurysm and the bulge. So as you can see, the normal aorta is the oxygen concentration is fine. And then as we go outwards, then the oxygen concentration gets less and less, which could then cause cell death.
So once we finished with the ANSYS modeling for the blood flow and arterial pressures, we moved our main goal of a computational model for the pressure drops of the blood through the aneurysm. So we use a software called FreeFrem++, which we use to simulate a propagation of a pressure wave through the aneurysm. Now this pressure wave allows us to see the pressure on the arterial walls from the blood and the displacement vectors of the arterial wall itself as well. When testing the flow, we were able to assess the energy loss through the aneurysm as well to see how much less the blood goes through. And one of the main things we studied also was the relations of the flow condition, pressure gradient, and the deformation, the wall deformation, through the different levels of stenosis. The different severities of stenosis obviously affected each of those components differently. And this is a picture of the plot we had. This is a diagram. As you can see, the flow going through the 2D aneurysm, and then the vectors at the top of the screen show the displacement of the arterial wall as well.
So one area that we want to expand this research in is, instead of using it for blood vessels, modeling vocal folds and air going through instead of the blood. So we've started working on this. We used MATLAB to generate like a pressure wave that would simulate like your pressure wave of you speaking. And then we implemented that into the FreeFrem++. And we also had to go through that code and change border properties and like fluid properties to mimic the folds in the air instead of the vessels in the blood. So the goal is to maybe see how different speech patterns affect like energy, and if the like native speaking versus non-native speaking takes more energy or not.